Hey everyone, welcome back to the Incredible India podcast series. I'm Sam.
And I'm Taylor.
And today we're taking you on a deep dive into a topic that honestly, well, I kind of broke my brain a little bit when we first looked at the sources.
Yeah, it's one of those things that really shifts your whole perspective on history, I think.
Totally. So like, imagine for a second you're zooming in on a digital photograph on your phone. You keep zooming past the landscape, past the trees, until the image stops being smooth.
You're right, it gets all pixelated.
Exactly. It gets blocky, and finally you hit this single, solid square of color, like one pixel. And you cannot slice that single pixel in half without completely destroying the image file, right?
Yeah, that's the absolute limit of the image.
Right. Now, imagine figuring out that our actual physical universe operates on that exact same principle. But not by using some supercomputer or a multi-billion-dollar particle accelerator.
Oh, yeah. No technology at all.
None. Just by sitting on a dusty road in ancient India, like over 2,500 years ago, with literally nothing but your own mind.
I mean, that is the staggering reality of what we're exploring today. Because we live in an era where, we rely on incredibly complex technology to understand physical reality.
Oh, for sure. Giant labs and lasers and stuff.
Exactly. But the sources we're unpacking for this deep dive, they provide this absolute masterclass in the sheer power of human deduction.
Yeah, it's so cool.
We're looking at a man who essentially deduced the atomic structure of the universe centuries before Western science even had a word for it. It really shows you what rigorous critical thinking can achieve.
It does. And to understand how an incredibly advanced theory like this even comes to be,
Yeah.
we kind of have to start with a moment that is just beautifully ordinary.
Yeah, a super mundane moment.
Like it's an action that you listening to this have probably done while daydreaming, completely unaware of the cosmic implications.
Right, so we need to travel back to the Gujarat region of India, and this is roughly between 600 and 200 BCE.
A long, long time ago.
Very. And we're meeting a philosopher originally known as Kashyapa. Now, historical texts also refer to him as Uluka or Kanabhuj, but history basically remembers him best by the name Kanada.
Canada.
Yeah, and that name actually translates from Sanskrit into something really fascinating. It literally means atom eater.
Okay, wait. Atom eater, because, that sounds like a sci-fi villain or something.
It totally does.
How does an ancient philosopher end up with a nickname like that?
Well, it comes directly from the legend of how he actually arrived at this foundational theory of physics. So the story goes that Kanada was out for a walk one day, just strolling down a dirt road, and he was eating a handful of grain.
Just a casual snack on a walk.
Exactly. And as he walked, he started idly snapping a single piece of grain in his fingers, like breaking it into smaller and smaller fragments.
Just kind of fidgeting with it.
Right. He'd break a piece, discard one half, and just keep going with the other half.
Breaking it down until the pieces were, probably almost too small to even hold in his fingertips.
Yeah, exactly. And at some point during this incredibly mundane, repetitive physical activity, this profound realization hits him.
The light bulb goes off.
Big time. He deduced that this process of division, it couldn't just go on forever. Like there had to be a physical wall.
Right, a stopping point.
He hypothesized a theoretical limit where that tiny speck of grain could just no longer be divided without losing its fundamental character. If you somehow managed to split it one more time, it wouldn't be grain anymore.
So he basically realized the physical universe is made of pixels. He just did it with, a piece of food instead of a smartphone.
That's a perfect way to put it, yeah. He called this ultimate, irreducible reality Paramanu.
Paramanu.
Right. And that word is highly specific in these ancient texts. So para implies something beyond, and anu means atom or tiny particle.
Oh, so like beyond division.
Exactly. Paramanu, that which is beyond division. And he concluded this limit wasn't just, a failure of his own clumsy fingers.
Or like not having a sharp enough knife.
Right. It was a fundamental law of the universe.
Okay, but a thought experiment about snapping a piece of grain? That's an amazing aha moment. But a moment of inspiration isn't science, right? So how did he take this sort of poetic idea and actually turn it into a rigorous framework?
Well, that transition from poetry to physics, that happens in his seminal text, which is called the Vaisheshika Sutras.
Okay.
Yeah, Kanada didn't just stop at, hey, things get small. He built this realization into a strict logical structure resting on 5 core proposals, or pillars.
5 pillars, got it.
And honestly, when you read these proposals today, it produces this massive sense of cognitive dissonance. It genuinely feels like uncovering the blueprints for a space shuttle buried in an ancient temple.
Okay, well, let's unpack those blueprints then. What's the foundation he built all this on?
So the first pillar is that concept of finite division we just talked about.
Right, that matter is not infinitely divisible.
Exactly. Every physical substance has an absolute endpoint. But once you establish that limit, you run into a pretty massive philosophical problem.
Which?
Well, if these tiny, indivisible particles are the end of the line, where did they come from? Like, are they just popping into existence out of nowhere?
Oh, I see.
Yeah. And that led Kanada to his second proposal, which is the eternal nature of atoms. He stated that Paramanu cannot be created and they cannot be destroyed.
Wow.
They existed before the universe as we know it formed, and they'll remain long after it dissolves.
Okay, I really want to pause on that for a second because for anyone listening who remembers their high school chemistry classes, that maps absolutely perfectly onto Antoine Lavoisier's law of conservation of mass.
Oh, 100%.
And that was published in, what, 1789?
Yeah, late 18th century.
Right, the whole nothing is created, nothing is destroyed, everything is transformed rule.
Right.
I mean, modern chemistry relies on that, and Canada laid that groundwork thousands of years earlier.
He really did. But, that realization naturally prompts another question.
Right, physics is just endless questions.
Pretty much. So if everything is made of indestructible, eternal dust that never changes, why isn't the world just a static, boring desert of particles?
Yeah. How do we get trees and water and living, breathing people?
Kanada answered this with his third pillar, chemical bonding.
Oh, wow.
He proposed that these indivisible atoms actively combine in various configurations to create the complex objects that we interact with.
So they stick together.
Exactly. The properties of a physical object are determined entirely by the types of atoms, the number of atoms, and how they're structurally arranged together.
He's literally describing molecular structure. That's wild.
It gets crazier. He takes it to an even more astonishing level with his fourth pillar, and this is arguably the most brilliant insight of his entire framework.
Okay, I'm ready.
Qualitative differences. Kanada suggested that atoms of different substances are fundamentally inherently different from one another.
Wait, which is anticipating the periodic table of elements.
Exactly.
He's saying an atom of oxygen is totally different from an atom of gold. Like they aren't just wearing different disguises, they have different masses, different behaviors.
Entirely different physical qualities, yes.
That is just wow.
And to round it all out, his fifth pillar provides the math, so to speak. He proposed the concept of definite proportions.
What does that mean in ancient terms?
Well, the Vaisheshika Sutras describe how 2 individual atoms combine to form a primary binary compound, which he called a divinuka.
Oh.
And then those binary compounds combine to form larger, more complex structures. The key here is that he recognized atoms combine in fixed, predictable, and specific ratios to create stable matter.
Okay, that perfectly mirrors John Dalton's laws of definite and multiple proportions from the 1800s. It's staggering to think about.
Yeah.
But I have to play devil's advocate for a moment here.
Sure, go for it.
Because I know what you might be thinking as you listen to this. We're talking about a guy living hundreds of years before the Common Era, without a microscope, without a laboratory. So isn't this just a lucky guess? I mean, ancient cultures have all sorts of creation myths. Some people said the world was on the back of a giant turtle.
Yeah, the turtle theory.
Right. And Canada said it was made of tiny specks. How is his idea actually science and not just a myth?
That is the essential question to ask. And the answer lies in understanding the larger intellectual ecosystem that Canada was operating in.
Okay.
Because this wasn't just an isolated lucky guess shouted into the void. It was part of the Vaisheshika school of thought, which developed a complete systematic realist ontology.
And just to clarify for everyone, an ontology being an attempt to basically categorize and map out everything that fundamentally exists in reality.
Exactly. The Vaisheshika school was attempting to replace mythology with strict categorization. They didn't just say, hey, atoms exist. They proposed distinct, exhaustive categories to classify the whole universe.
Like what?
Well, to show you how sophisticated this was, let's just look at 2 of those categories. First, they had dravyam, which translates to the actual physical matter or substance.
The atoms themselves.
Right. But they distinctly separated that from a second category called guna, which means quality or property.
Oh, so they were separating the physical object from its attributes.
Yes. They realized that a property like heat or color isn't a physical substance you can hold in your hand.
Right, you can't hold a handful of red.
Exactly. It is a quality inherent to specific arrangements of matter. And this is a massive leap in human reasoning.
Yeah, I can see that.
It's the difference between saying, the angry gods are throwing fire from the sky and saying, let's categorize the physical properties of lightning, the substance of the clouds, and how those different categories interact.
That makes total sense. It was philosophy of the highest order.
Strictly from first principles and rigorous logical deduction, yeah.
Okay, so to truly appreciate the magnitude of Kanada's genius, especially that fourth pillar you mentioned, the idea about atoms having inherent qualitative differences, we need to zoom out for a second.
We do.
We need to look across the world at what the ancient Greeks were doing at the exact same historical moment.
Yeah, it is one of the most extraordinary examples of parallel intellectual development in human history, really.
Because over in Greece, around 460 to 370 BCE, you have Democritus. Now, Democritus is a name you probably did hear in your middle school science classes.
No, certainly.
Right. He independently came up with a very similar concept and coined the term atomos, meaning uncuttable. So we have two major civilizations with zero contact with each other, arriving at the same fundamental conclusion.
About the irreducible nature of physical reality, yeah.
Yeah.
But there's a crucial fundamental difference between what Democritus proposed and what Canada proposed.
Really?
Yeah, and this divergence is everything when it comes to the history of science.
Okay, break it down.
So Democritus believed that all atoms were made of the exact same uniform fundamental stuff.
Okay, so they were all basically identical material.
Right. He theorized that the only difference between atoms was their quantitative features, like their shape, their size, and their physical arrangement.
Interesting.
So in the Greek model, water flows because water atoms are smooth and round. Fire hurts your skin because fire atoms are sharp, jagged, and spiky.
Ah, okay. So the Greek model is basically taking identical plastic Lego bricks and just snapping them together into different shapes. Like the plastic itself never changes, just the structure.
That is a perfect visualization. But Canada, as we discussed with his fourth pillar, argued for qualitative differences.
Right, the different types of atoms.
He intuited that an atom of Earth is not just a differently shaped piece of the same basic stuff as an atom of water. They are fundamentally, inherently different kinds of entities altogether.
Wow.
And as 2,000 years of subsequent scientific progress eventually proved, Canada got it right.
Think about how wild that is for a second. Like, the modern periodic table proves this unequivocally.
Yeah, it does.
A hydrogen atom is not just a smooth, round iron atom. It's a totally different entity with totally different properties.
Yeah.
I mean, the physics that powers the battery in the device you're using to listen to this deep dive right now, it rests on a philosophical framework dreamt up by a guy analyzing grain on a dirt road.
It's incredible. But, in the spirit of absolute intellectual honesty, we do have to give credit where it's due here.
Okay, fair enough.
This isn't about declaring a winner between ancient civilizations. Democritus made a massive, crucial contribution to physics that Canada's framework actually missed.
Oh, the concept of the void?
Yes, the void. Democritus realized that for these tiny atoms to move around, collide, and combine, there had to be empty space between them.
Which makes sense. They need room to move.
Right. He conceptualized the void, a true vacuum, as a physically real entity, and that is a massive leap in physical thinking.
And Indian philosophy struggled with that.
Yeah, they struggled with it because of their views on space as a continuous substance. So if you want the complete, accurate picture of ancient atomic thought, you really need to synthesize both traditions.
That's a really good point.
Yeah.
Okay, so if Canada got the qualitative nature of elements right in ancient India, and Democritus gave us the concept of the void in ancient Greece, why does a guy named John Dalton, sitting in a British lab in 1808, get the official title Father of Modern Atomic Theory?
That's the big question.
Right. What actually happened in that massive 2,000-year gap?
One word. Measurement.
Measurement.
That is the threshold that changed absolutely everything. Dalton brought empirical, experimental proof to the philosophical framework.
So you proved it.
Exactly. Canada and Democritus gave us brilliant reasoning, but Dalton connected that theory to measurable, observable chemical reactions in a controlled environment.
How did he actually do that, though, without modern equipment, like in 1808?
Well, building on the work of chemists like Lavoisier, Dalton used closed vessels to actually weigh gases before and after chemical reactions.
Oh, wow. So he was tracking the mass.
Yes. He physically demonstrated that elements combine in specific mass ratios. He introduced the concept of atomic weights, assigning relative masses to different elements based on how they interacted in his lab.
So he took Canada's concept of definite proportions and proved it mathematically.
Exactly. He turned chemistry from a qualitative philosophy into a predictive quantitative science.
Okay, so going back to that earlier pushback I gave you about whether Canada's work was actual science, it really was the absolute necessary precursor.
It was the foundation.
The way I look at it, Canada was like the brilliant architect who drew these flawless visionary blueprints for a skyscraper. He saw exactly how the building needed to be structured to survive.
I love that analogy.
But Dalton was the structural engineer who came along centuries later, invented the physical steel, worked out the load-bearing map on paper, and actually proved the building could stand up in the real world.
The architect and the engineer. That perfectly encapsulates the relationship between ancient philosophy and modern science, yeah? Dalton made it mathematically actionable.
Right.
But if we fast forward from Dalton's 19th century lab all the way to the 21st century, modern quantum physics has actually brought us right back to Canada's original doorstep.
Wait, really? You mean beyond just the periodic table?
Oh, way beyond.
Yeah.
Consider the standard model of particle physics.
Okay.
When physicists look at fermions and bosons, which are the absolute most fundamental subatomic particles we currently know of, they are not just differently configured versions of the same cosmic substance.
Oh, so the Lego brick thing again.
Exactly. They are genuinely qualitatively different kinds of things. They possess different fundamental properties, different masses, different electrical charges, different spins.
Just like Canada's fourth pillar said they would. Like, the deeper we zoom in, the more diverse the fundamental pixels actually become.
It's astonishing. When CERN discovered the Higgs boson in 2012, the particle that gives other particles mass, sometimes called the God particle.
Right. Huge news.
They were discovering a qualitatively distinct entity. It's a completely unique kind of thing, not just a physical rearrangement of something else.
That is just, it's beautiful, honestly.
Yeah.
And there's a really cool full circle connection there, too.
Oh, yeah.
Because the word boson, in the Higgs boson, it actually honors Satyendra Nath Bose, a brilliant Bengali physicist.
Yes.
Which perfectly transitions us into looking at the actual geography of this genius. Because ideas like Canada's, they don't just spring out of a vacuum.
They definitely don't.
Where did the intellectual foundation for this level of brilliance actually come from?
Well, it emerged from a landscape with incredibly deep historical layering. So Canada was born in Kshetra, which is near Dwaraka in modern-day Gujarat.
And for you listening, if you pull up a map of that specific region in India, you'll see it is steeped in deeply sophisticated ancient civilization.
Oh, absolutely.
This is the exact same landscape as the Indus Valley civilization sites, places like Dholavira and Lothal.
And the historical context is vital here. 2,000 years before Canada was even born, the people inhabiting those Indus Valley cities had already developed highly standardized weights and measures.
They were doing math, basically.
High-level math. They were building complex, grid-based urban planning systems and sophisticated sewage networks.
Yeah. The site at Lothal even features the world's earliest known dry dock.
Which is mind-blowing.
It is. That means they were engineering massive maritime infrastructure. They had to understand tidal flows, big waterproof bricks, and they were engaging in deep-sea trade with Mesopotamia.
Right. And a civilization that can engineer a functional dry dock is a civilization that deeply values mathematics, physical observation, and rigorous structural logic.
So they were already primed for this kind of thing.
Exactly. So when Canada sat on that dusty road thinking about the ultimate division of matter, he wasn't doing it in an intellectual vacuum.
He wasn't starting from scratch.
Not at all. He was the direct inheritor of thousands of years of accumulated human intelligence and observation native to that very specific geographical region.
Wow.
It's also the same sacred landscape as the Somnath Temple, a structure famous for being destroyed and rebuilt 17 times across history. It really represents this profound cultural continuity.
And what's amazing is that cultural and intellectual continuity doesn't just stop in the ancient world. It bridges right into modern quantum physics.
It does. The philosophical tradition that Canada founded, the Vaisheshika school, remained a highly influential framework in Indian intellectual life for over 2 millennia.
That's a long time.
Yeah. And you can draw a direct, unbroken line from that ancient tradition straight into the 19th and 20th centuries, specifically landing in Kolkata.
Ah, the era of the Bengal Renaissance.
Yes. At places like Presidency College in Kolkata, you have this extraordinary localized concentration of scientific genius.
Like who?
We're talking about minds like Jagadish Chandra Bose, Meghnad Saha, C.V. Raman, and of course, Satyendranath Bose.
The namesake for the boson particle.
Exactly. And these scientists weren't just learning Western physics in a vacuum. They were deeply engaged in merging their native ancient Indian philosophical traditions with the absolute most cutting-edge modern science.
So they were actively using Canada's ancient ontology to help them navigate the bizarre, counterintuitive world of quantum mechanics.
Yes, Satyendranath Bose's pioneering work on quantum statistics, which Albert Einstein himself recognized as a fundamental breakthrough, it operates in the exact same philosophical territory that Canada identified 2,600 years earlier.
That gives me chills, honestly.
It deals with the inherent qualitative distinction between different kinds of fundamental particles. It is this continuous intellectual thread running from a dusty road in Gujarat through the academic laboratories of Kolkata and eventually all the way to the Large Hadron Collider at CERN in Switzerland.
It is genuinely awe-inspiring to think about the timeline of human thought. To realize just how deeply connected the ancient world is to the very frontiers of modern physics.
It really is.
It proves that the human mind, when given the space to observe and reflect, is the most powerful instrument we have.
Absolutely. And if we connect this to the bigger picture, it raises a deeply important question, I think.
Yeah.
We've just spent this time tracing how a single mind, using only careful observation and rigorous internal logic, managed to unlock the invisible structural secret of the universe.
Just a guy with a piece of grain.
Right. Which brings us to a final thought for you to ponder on your own after this deep dive is over.
Let's hear it.
If Canada could deduce the atomic structure of reality through pure, quiet reasoning, just by closely observing a single grain of food breaking apart in his fingers, what profound truths about reality are we entirely missing today? Are we simply too distracted by our screens, our constant notifications, and our over-reliance on supercomputers to just sit, think, and truly observe the world right in front of us?
If you decide to travel to India, we have a recommendation. 5 Senses Tours organizes tours across India, which are immersive cultural experiences. You can email contact@5sensestours.com. Note 5 is written as a numeral in contact@5sensestours.com or WhatsApp 2 +919 845 677 446.